the K trend, okay, as K increases, what is the trend of the root locus? And then also to talk about few other important things that I feel important. Okay, so this is the first. So I have uh five diagrams over here. Okay, so what are these all five diagrams? Okay, this is when this is without any integrator. This is when you have a simple integrator, a double integrator, a triple integrator, and a quadruple integrator. If you remember in the integrator videos. So let's take a look as the k varies. How does it move? Okay. So in the simple without integrator, like as k increases, as you can see, it is coming. It is coming from this side. Okay. The 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 angle it's kind of much larger. Let's say if you were to compare. Same. Okay, sorry. Angles are the same, just that the magnitudes are different. Okay, as you can see. So let's say if I were to draw a line, okay, definitely the angles are all the same. But however, is you can see that the magnitude it composes of different lengths already, right? So if I were to take a look, right, let's say this is let's say this magnitude is let's say over here is let's say 0.1, right, and then over here is about 0.05, right. If we were to compare to this, which is 0.3, and then somewhere over here is 0 minus 0.1. If you were to find the magnitude, okay, this blue line's magnitude will be smaller than this magnitude over here, right? If you were to calculate 0.1 square plus 0.05 square root. Okay, so this calculation is for the blue color one. Okay, if you were to calculate, you have some values. It will be 0.11118, something like that. Okay. Then if you were to calculate for this blue line, I mean this brown line, okay, you have 0.1 square um plus 0.3 square. Okay, it will be much larger. Okay, so the values itself is 0.316. Okay, it will be 0.316. As you can see, it's relatively larger. As the gain increases, the k increases, definitely the gain magnitude will actually increase. This is the thing. So as you can see, this is why it comes into from a steeper slope. Okay, so as you can see, the trend itself is pretty straightforward. Okay, where am I? Okay, so it comes in from, maybe my pen is too big. So when it comes in from a more higher places, okay, it comes in from, as you can see, it comes in with a large degree, okay, with a large turn, okay. As you can see, for 1 over s times 1, 1 over s plus 1, you see it also comes in from a higher angle. Okay, so if you, let's say if it's 0 degrees, okay, so it's like this. You come in from a higher degree. You come in from the higher angle lah. Although they are same angle, but then okay, although they are same angle lah, okay, fine, whatever lah. Okay, although they are the same angle, but then they 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 turn in a more steeper way. Okay, they turn in into a more steeper way. Just to think about it. So if it's 0 degrees, it turn into the origin in a steeper way. If it's minus 90 degrees, okay, it comes in at this real axis. Okay, comes in a more steeper way. And then similarly for if it's minus 180 degrees, which is minus 270 degrees, which is over here, right? Somewhere that eats into, okay, that eats into, if you have a real axis continue, it is minus 270 degrees. If you remember, this is a third order system. Definitely it's because it's 3 poles, 3 poles is minus 90 degrees times 3, right? Because there's no zeros above. But as you can see, as k varies, it comes in from a higher value. from that particular quadrant. Okay, it comes in from the steeper one. So definitely, in other words, just remember one thing. Okay, if you are in the first quadrant, maybe not. Okay, so the k, as k, smaller k will tend towards the origin, will be nearer to origin. You just think about it. Okay, so smaller k value will be nearer to the origin. Okay, will be nearer to the origin. Okay, so similarly, as you can see, is nearer to the origin. As you can see, although in this manner, okay, for s cube, okay, we can't actually describe how to where is nearer to the origin. So we need to come in from, let's say if you are 360 degrees, right? You just think about a swelling manner. How do I talk about? Okay, just think about this manner. Okay, if you are at this quadrant, okay, typically the green color one will be in this portion over here. Okay, so just remember this portion, and then for which quadrant you are in. Okay, let's say if you are minus 180 degrees, so definitely your root locus will comes in like this, right? So if this is the case, and then you just flip lah. Okay, you just flip. So I flip. As you can see, it's like that. As if you were to flip again, it comes in this manner. As you can see, hold on. I don't know where I stopped, but okay, I think I know where I stopped. When I label k equals to 1, k equals to 2, k equals to 3, okay, you just simply see the trend. Okay, I can't explain it because it's simply the trend. So if I have to rotate, okay, k equals to 1, k equals to 3 is in this direction. Okay, if I were to rotate again, k equals to 1, k equals to k equals to 3. As you can see, it's, if I rotate again, this is k equals to 1, k equals to k equals to 3. So I hope that you can understand the trend. Okay, so this is how it goes. Okay, so in which quadrant you are in? Okay, let's say you're you're in this quadrant. Okay, this is actually negative 270, right? You're coming in from this side, right? So the larger the k, you're coming in a larger radial. I mean larger angle, I'd say. As you can see, if it's 270 degrees, which is actually this one, right? As you can see, k equals to 3 is coming in a larger area. So this is just that trend itself. Okay, so let's come back to the phase and margin. So if you remember our previous video, we talked about this root locus, right, coming in this direction, right? Um, one one this is actually it's actually coming from this direction. Shit. Okay, hold on. So just a reliability check lah. Okay. So if you are why I'm coming from here? Why am I negative 270 degrees? Okay. Why am I? Which quadrant am I? Okay, we are, and then which integrator? Okay, which integrate in this diagram? What order is this? What order is this root locus? Okay, this is the first thing, right? I think this is the only thing, okay. The order is actually third order, okay. There is negative 90 degrees. There to be exact, there is third order in the poles, okay, in the poles. This is why it's moving. If you remember, the zeros contributes negative 90 degrees. For the poles, it contributes negative 90 degrees. Zeros contribute 90 degrees, poles contribute negative 90 degrees. So in this case, since we have minus 90 degrees, minus 90 degrees, we are the second quadrant. So therefore, this is actually the 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 third order system. So in other words, it may be 1 over s squared, s plus 1. Okay. So the larger the k, okay. So in this case, if let's say the k is larger, right? So the larger the k, the more it comes in from here. Okay, actually this shouldn't be 1 over s squared lah. Okay, sorry, this is my fault. Okay, please. Okay, sorry. This is actually 1 over s. Okay, if you remember, at 1 over s square. Okay, if you remember, okay, this integrator only flipped the graph by 90 degrees. Okay, this integrator flipped the graph by 90 degrees. So if let's say if you are 1 over s plus 1 square, right, your root locus should be in this direction, right? Correct? If it's 1 over s plus 1, so without this one, okay, it's actually this. Okay, if you don't believe, hold on. So my y, okay, is equals to s squared plus 2s plus 1, which is s plus 1, okay, s plus 1 square. Okay, if you remember, so my t is actually 1 over s plus 1, right? So if I t times t, I have 1 over s squared plus 2s plus 1. And then I plot a nyquist plot. I have this shape. So this shape is the same as my shape over here, right? And then if I were to flip, okay, if you remember, if I were to introduce a one integrator, you're actually flipping the graph in a 90 degrees manner. Okay, you're flipping it over here now. Okay, so if I want to, so if let's say I switch again, okay, let's say I um g is equals to tf1, and then so if you can see, this is 1 over s, right? So if I multiply g times y, g times t lah, okay, since this is t times t, okay, and then I were to plot root locus, I mean nyquist plot, sorry, um, g times t, okay, so you have to plot g times t. As you can see, I'm coming in from here, this direction, right? If it's longer lah, okay, I'm coming from this direction. And if you were to look in a more detailed way, okay, we're actually um, coming in into the axis in the third quadrant, right, which is exactly shown over here. We're coming in the, not third quadrant but second quadrant. So if you were to take a look, okay, we are coming in, and then instead of ending at this third quadrant, okay, so there will be because it's 0 so there will be in other words, this is actually the whole axis, right? And then this is actually the -1 radius. So in this case, we are unstable lah, right? We are unstable at this point. And if you were to come in and do this manner, okay, it's actually eating into the third quadrant, okay? Because as you can see in the nyquist plot, okay, I didn't draw well over here, but as you can see, if I were to zoom in, okay, it actually comes into the second quadrant, okay? So this is the second quadrant, this is the third quadrant, this is the fourth, this is the first. So it actually comes in this portion over here. So I just want to sidetrack a little while and then show you that the particular thing that is pretty much interesting. I mean, yeah. So hope that I didn't confuse you or anything. Okay, so to summarize again, the purpose of this video is only to show you the trend. If I have root locus in this direction, if I were to rotate one time, okay, this is the trend of when k increases, you're moving towards that axis and moving towards that piece of thing. Okay, and then it's over here. Yeah, the k increases. You just remember the very first picture. This is when you're coming in this direction. So just remember this piece will do. You just remember this piece will do. K equals to 1, k equals to 2, k equals to 3 at this section. And if you have any question, I mean if you have any, so if you have any other questions that maybe at this point, what is your answer? So what is when k, so if you have k equals to 1 over this green line, you want to know as k varies, is it going up or is it going down? So we can straight away use this method to determine my that particular graph lah. Okay, so I hope I didn't confuse you anything. I hope that it will be a very value added one. So I'll see you in the next video for cross negative axis. Later I'll talk about it. So see you.